Good afternoon, everyone. Thank you for joining us today for our presentation on customized foundational models for generative AI applications with Amazon Bedrock. My name is Kishore Aher. I am a Principal Product Manager for Amazon Bedrock team. I have with me Anand, who is a Senior Director NYSC, and Chris, who is a Principal Solution Architect. So, what is our agenda for today? We're going to introduce you to the foundation model customization. So we'll discuss why customization is needed. We'll introduce you to fine-tuning and continual pre-training. Then I'll talk about Amazon Bedrock custom models. Then we'll go through customization of Amazon Bedrock models at NYSC. And then we'll have Chris demo us fine-tuning and continual pre-training with Amazon Bedrock. So why customize? I'm sure you all know that foundational models are built using large amount of public data, and this is generic data. And when you try to build applications, you can generate generic results, but you want it to be specific to your use case with your data. So customize to specific business cases, like if you are a healthcare, in healthcare industry, and you are building an application, generative AI application, it is important that the foundational model understands the terminology of healthcare to generate the responses. Or adapt to a domain-specific model, like if you are in finance, like my friend here, Anand, finance has a different terms and terminologies, and it's completely different domain-specific language, and you want the foundational models to understand that. Or if you are in customer service, you want your responses to be friendly and very specific to whatever the questions your customers are asking. And then lastly, if you want to improve the context awareness of your responses, when let's say a customer is interacting with a generative AI chatbot and you are asking a question about a specific thing, you want the Gen AI application to generate a response in that specific context. So now we know why customization is needed. Let's look at the common approaches for customizing foundational models. And we will look at based on the least time, cost, least quality, and complexity. So first is prompt engineering. Is the easiest way. You use either a zero-shot or few-shot examples, and you send it to the foundational models, and it will generate a very generic response and give you back the response. So it's very easy to build prompts, test prompts. They are very cost-effective because you just send the prompt and you get the responses, and the least complexity in doing prompt engineering. The next would be retrieval augmented generation. This technology helps you bring the data from outside. So you take your large amount of data, you create embeddings, you store it in VectorDB, and whenever you require to fetch this information, you search the data, you fetch the information, and you inject this information into your prompt. And this will generate very specific results based on the context you provide from the documents. But it's, of course, a little bit costly. Now you have to create embeddings, and there is a complexity because now you have multiple systems involved. Next would be customization. Now, if you have recurring data which lives outside the model and you want to bring this data inside every few weeks or months, you would want to customize, and we will look into the different customization techniques. And then lastly, you will train the model from scratch. For this, of course, you need infrastructure, you need to have data scientists, you need to have large amount of data to train the model. So it is most complex, and you will get the best quality, but not cost effective and will require a lot of time. So now we have seen that the simplest was prompt engineering and the complex was training from scratch. But let's look at the middle two options, customization versus augmentation. So we start with task. What is the task you are trying to achieve? If your task requires external data and up-to-date information, then next is you should ask yourself, do I need real-time information? And if you don't need real-time information from APIs or databases, you just need information from documents, then you would use augmentation with RAG. And for that, you can use Amazon Bedrock knowledge bases. If you need real-time information, that means you're going to a database or you're querying APIs, then you would use augmentation with agents and tools. And for that, you can use Amazon Bedrock agents. If your task requires a consolidated or historical information, then you have to ask that, is it a simple task or not? If the task is very simple and generic, as we discussed earlier, you would use prompt engineering and any model of your choice to get the results. And lastly, if the task is complex and requires a specific behavior, you would use customization. And that is supported by Amazon Bedrock custom models. So what are the types of customizations? There are two types of customizations. One is fine-tuning, and another one is continued pre-training. With fine-tuning, you're trying to achieve a task-specific performance, like style. Or, for example, let's say you want to summarize a document, and you want to summarize a document in a specific format. Then for that, you would fine-tune a model by giving it examples. And then the next one is continued pre-training, where if you want the model to learn specific terms and terminology or like large amount of domain-specific data, you can bring that unlabeled data and train the models using continued pre-training. You can also do combination of both. You can first train your model with large amount of data which is specific to your organization, and then later fine-tune that model, same model, for a specific task. So what are the data set requirements for fine-tuning and continued pre-training? For fine-tuning, you need prompts and you need completions. So you have to show the model that for a given type of input, what kind of output should be generated. And then a model generalizes it and learns from it. And for continued pre-training, you just need raw data. You just bring the raw data, which has like all your documents or like any other libraries. You can bring the raw data and train the model using continued pre-training. So let me introduce you to Amazon Bedrock custom models. You can maximize the accuracy of foundational models by providing labeled data or unlabeled data using the same API or console. You can deploy it using provision throughput and use it either through the API or through the playground, a customized model. And lastly, we support both first-party and third-party models for fine-tuning and first-party models for continual pre-training today. So let's look at components of customization job. And these components are same for both fine-tuning and continued pre-training for Amazon Bedrock. So what are the inputs? The inputs are, first you select the base model, which you want to customize. Then you provide the hyperparameters. Now, hyperparameters based on the model providers, some model providers may give you like default hyperparameters, or some model providers may give you option of hyperparameter optimization. It depends from model provider to model provider, and we support both on Amazon Bedrock. And then the input data. You saw the format for fine-tuning and continual pre-training. You just need to provide that input data in JSON-L format. Next is output. So you have to point to a S3 bucket and a folder in S3 bucket where we would generate the metrics like training and validation logs and store that metrics and any other logs into that folder as a log file. And you also have to provide the output model name, which will be used once the job is completed to name the model. Next is the storage. Now, the custom model which you generated is stored securely within Amazon Bedrock. And you can deploy it right within the Amazon Bedrock using provision throughput. And lastly, inference. As I said earlier, once you deploy it using provision throughput, you can use the model using invoke model API like any other base model or using playground. And last, let's look at the security and privacy. So data used to improve your models is not shared with any model provider, both first party or third party. Customer data remains within the Amazon region, and we support both private link and VPC configuration for security and integration with IAM roles. API monitoring is available through CloudTrail and CloudWatch, and custom models are encrypted either using the service key, or you can provide your own customer managed key for encrypting the model. Now, I would like to invite Anand on the stage to talk about continued innovation and generative AI implementation at NYSC. Thank you.
Hello, everyone. Thrilled to be here and thrilled to see such a massive turnout for an event which is scheduled towards the tail end of the reInvent. I'm Anand Pradhan. I'm a Senior Director of Technology at New York Stock Exchange and part of the technology leadership team. I started my journey in technology about 2 decades ago, and I have been with New York Stock Exchange since 2007. Started as a C++ engineer in medical imaging, and then at New York Stock Exchange in matching engine development. Then moved to low latency, high throughput market data consolidation system, then to regulatory technology, and then to machine learning. For a technology enthusiast like me, I find reInvent quite fascinating. So many great technology ideas shared by not only the emerging technology company, but also well-established companies. It provides a great opportunity to share our thoughts and learn from each other. So I'm here to share some of our learning and talk about Bedrock customization. Now, how many of you have heard about New York Stock Exchange? I guess the better question would have been who has not heard about New York Stock Exchange? But before I talk about New York Stock Exchange, let me talk about our parent company, Intercontinental Exchange, or as we say, ICE. So ICE is an integrated data and technology company that connects people to opportunity. We are a global financial organization with operating exchanges, clearing houses, data services, and mortgage technology. We provide connection between data and technology, innovation and expertise, and ultimately between people and opportunity. We help companies to raise capital so that they can change the world. New York Stock Exchange, under ICE's umbrella, is the largest stock exchange in the world. We have 5 equities exchanges and 2 options exchanges. Recently, we celebrated 231st birthday of New York Stock Exchange. We have come a long way from the days of open outcry trading on the street to fully automated electronic trading. Today, we trade more than 11,000 equities and ETF in our equities platforms and more than 1.6 million options series. Between all our systems, the record transaction that we have handled between 9:30 and 4 o'clock is 500 billion messages in a single trading day. That's trillion with a T. And the number keeps on growing every single day. Now, all these things doesn't happen without constantly being innovative and trying to stay ahead of the curve. In this 200 years, we have many stories of innovations, right from using pneumatic pipe to send orders to reduce the latency, to have the first ticker tape to transmit stock trading data, or to have the first building to have commercial air conditioning. To talk about some of the innovation in recent times, let me touch upon the core trading platform that we run. So we run massive data centers and a very sophisticated global network to transmit our data. Now, you know that across the globe, the compute generation has been improving every single day. And also with the evolution of new trading techniques, the complexity and the volume of data keeps on growing every single day. And because we are at the center of capital markets, invariably all these data sets end up in our exchanges. So we need to be constantly be thinking about how we can improve and be prepared for the next generation of computer that comes, next generation of trading system. Just to give you some perspective, a single market data feed of ours produces more than 150 billion transactions between 9:30 and 4 o'clock with under 20 microsecond latency every single day. And this number has grown almost 2.5 times in last 1.5 years. So we spend a lot of time optimizing all our trading platform that runs in low latency. Now, once we finished our optimization on our trading platform and we keep on lowering our latency, the next big challenge that we had was how do we monitor all the transactions that happens in our exchanges so that our regulators can surveil the market. They can look at each and every transaction and they can make sure that people, whoever is trading, they are following our rules. So when we were thinking about a platform which is ready for the future, Sridhar, our CTO, who is here in the crowd right now, him and I were brainstorming, and we came up with the idea that why don't we use cloud computing and why don't we migrate this to AWS? It's a beautiful hybrid architecture. We run less than 10 servers in our on-prem. It absorbs all the microbursts that happens, and then we have a small pipe going into AWS. In real time, we collect all the data, and in the night, we spin up about 150 to 200 servers to process all these data sets. I covered this in the last reInvent in detail. I'm not going to get into the details, but if you are interested, that session is there on YouTube. We use more than 40 different AWS services for that application. And that was the first application that I led to be migrated to AWS Cloud for NYSC and ICE. As an organization, we learned a lot. And because of that, many new initiatives on the cloud that we embarked upon after that. That also paved the way for our Snowflake migration, where our enterprise data warehouse runs. We also have market data products like our historical trades and code product is delivered through AWS S3. We look at cloud as a third-party tool, but we have the same set of regulation and compliance that we use for our on-prem infrastructure. We evaluate cloud for many aspects like functional viability, performance, time to market, and at the end, cost. And many new initiatives are coming up on the cloud because of that. I feel like we optimally use cloud wherever it is needed. Taking it to the next level, when we were thinking now that we are able to operate in the cloud, we recently launched a program called NYSC Launchpad. This is the next chapter for our continuously evolving market conditions. And because we help companies to raise the capital and change the world, we started engaging with many emerging technology companies. So the idea is that can we provide valuable feedback to these companies, So this program basically, we use a vast technical expertise that we have across ICE because we have solved complex problems. So the idea is evaluate the product, test it, and the companies can receive actionable insights. And at the end, we have NYSC's unique visibility platform to share their innovation with a broad global audience. And the next one, GenAI. So before GenAI, once we finished our migration of our regulatory surveillance platform to AWS Cloud, and our day-to-day operational challenges were behind us, Sridhar and I were brainstorming, and I said that let's invest in machine learning. And at that time, LLM was not the talk of the town. So Suresh, who is a machine learning expert, he joined our team, and we started building a team around machine learning. The whole idea was that how do we find patterns in a time series data using ML models. So by the time GenAI became the flavor of the season, we were ready. Our team was ready, our pipeline was ready. So many new innovative stuff, and we are actively investing time in GenAI. And because we are a highly regulated exchange, we try to understand each and every aspect of the pipeline. We understand what it takes to have a platform running using GenAI. So we are, as I mentioned, we are doing quite a lot on GenAI, but let me take you through one of the use cases that we build using Bedrock. So being a lawyer's son, I grew up around legal terminology like pro bono, de novo, sine die. Understanding all these legal jargons can be like deciphering a secret code. Back in 2007, when I joined NYSC, I couldn't understand any of the trading rules just by reading the legal documents. So I used to look for team members who would simplify the explanation and give me something that I can understand. Depending on the workload and mood of the individual, I would get a varied response. At that time, I truly understood the meaning of subject matter experts. So when we were brainstorming, what can we do with GenAI, this use case came into the picture where we thought, why don't we take all these legal documents or trading rule documents that we have for all US exchanges, not limited to NYSC, and build an intelligent trading rule chatbot. So we took about 20,000 pages of documents, and then we created this chatbot. So what was the idea? The idea is that can we increase the traceability of the rules to requirement to test cases? Can you get a simple explanation of anything that we can ask? Can we mitigate the risk for our compliance requirement for trading rules? And can we optimize our talent utilization by not relying on domain expertise, but strictly relying on the technical talent? And also, as I said, we always try to stay ahead of the curve. So the rules are changing every now and then, so we could stay current. And this also becomes a reference framework for other use cases that we have at ICE. So if you look at the example I have here we are asking this chatbot, can you explain me cube orders? Now it gives me an explanation that I am able to understand. But the main aspect of this chatbot is able to understand the context, right? So we ask a follow-up question. Is there an equivalent of cube order in other exchanges? Clearly, it gives me an order type in other exchanges, which has the same underneath criteria without having the same name. So the model is able to understand all the behavior of that order by going through the documents and give us that insight. I find it quite fascinating to have this and to be able to build this with ease. So talking about the architecture here, before I talk about the Bedrock, so let me tell you that when we started building this pipeline and Bedrock was not ready at that time, we spent a lot of time, starting from like taking a VM, doing fine-tuning manually, to trying everything in SageMaker, having different kind of vector databases and things like that. But when we were working with AWS team, Kishore said that you can do all these things in Bedrock, so why don't you try it? And in matter of days, we were able to put together this one, where there is a chat app running, and we have embeddings running. Our documents are on AWS S3. And we are using vector databases here for storing our embedding. Now the question and context goes to the foundation model, and then we get the response, right? I would like to call Redis here because they have been a great partner for this one to solve this problem. And this is probably not the only one where we will be working closely with them. They provide a great vector database solution. So just to talk about the customization, we tried different kind of models, Anthropic Claude, Titan, with and without fine-tuning, Llama 2, Jurassic 2, to name a few. And we tried every kind of possible combinations, like try with fine-tuning, with RAG, Why don't we do some prompting on top of that and try with RAG? Can we take a foundation model as is, like Claude, and see what it does? And we are able to do all these things very easily in Bedrock. So that was a game changer for me. I keep talking to our team members. Then within a few days, the thing that we are able to put together here is quite amazing. The other initiatives that we are actively working on at ICE, the first thing actually that we started for Gen AI was the news sentiment analysis and correlation. So we have a news feed where we get unstructured data. We feed into one of the Gen AI model, which summarizes. Then we feed the data into another model, which predicts whether the stock price will go up, down, or stay neutral. Then we also are building network traffic anomaly detection, data quality check, email parsing for bond pricing, convert complex OTC structures, fraud detection, and mortgage lifecycle. Lastly, I would like to reiterate the program we launched, NYSC Launchpad. It is to help today's entrepreneurs, and we have a vast technical expertise, so you can leverage that. And this is a secure cloud-based platform that we have. And the products and application will be evaluated here to receive actionable insight on the product. And last but not the least, we have NYSC's unique visibility platform. With that, thank you, and I'm here after the session for any other questions that you have.
Okay. Who here wants to see some code? Everyone? All right. Thank you. That's my job. And I gotta hit this. Oh. Demo. Okay. All this code, by the way, is available at this GitHub repo. And I'm going to do 2 demos today. I've got the notebooks already run just because of time's sake, but these are real like notebooks that you can run in your own environments. So this one's going to fine-tune Llama 2. We're going to use a chat dialogue, well, actually not chat, but more of a like summarization, right? Like conversations, trying to summarize conversations. So we're going to fine-tune with some of that data. We're going to use Bedrock with Llama 2. This is the 13 billion, but you can use 70 billion as well. And so what I'll do, and the second demo will be continued pre-training, where we're going to feed in PDFs of large books and documents and see how it changes the model. So in both cases, I'll show how to set up, I'll show how to test the base model before the fine-tuning or the continued pre-training, also called customization. We will upload, so we'll then prepare the data set for the customization. We'll then upload to S3. We'll actually run it and then provision that custom model as a like endpoint that you can hit with the API. And then we'll test the customized model, and then for cost savings, we always recommend delete these endpoints when you're not using them. Okay, so here's some pip installs, pretty familiar stuff. This is the Hugging Face datasets library, where we're going to get the public data set from, setting up some pandas action here, and doing the imports. This here is really for the Bedrock sort of control plane. This is how you would launch your customization job. So we just get that into a variable here, Python variable. Now the runtime, that's for the inference side of it. So they've been split. So I think of it as control plane and then data plane. Okay. So I've got those comments there. Here I can actually search for, show me all of the meta models. I could put the Amazon models in here. I could put Cohere. Show me which ones support fine tuning. And I get this list here. So for time and cost sake, I'm just using 13 billion, which actually has pretty good results. So we'll stick with that. So we just grab that ID, put it right here into the variable. Now, here's a sample conversation. And the key here is I'm asking the model to summarize just the simplest and the most interesting parts of the following conversation. Okay? And this is Llama 2 through Bedrock, no customization. Got some of the inference parameters here, temperature. I put it kind of medium, so we'll give it a chance to explore. And here's how you invoke it. And this conversation is, the key elements here really are this person's checking in, person 2 is the person behind the counter at the hotel. They're asking for a particular credit card. They don't support Amex, they only support Visa, MasterCard. I'm sure some of us have experienced that. Person does check into a non-smoking and everything is good. So this is Llama 2 13B without any customization, and it's pretty much describing everything that's happening, right? So not bad, but I just want the simplest and most representative parts, the most interesting parts, okay? So here's how we're gonna tune it to sort of shrink down the response and focus only on the most important parts. We're gonna use this data set called dialogue sum. We're gonna get it from Hugging Face using the Hugging Face library. I have deep links in here in all the notebooks so you can get to the actual data set. Here's a sample, just the first row that comes back. Person at the doctor. Yeah, this is a public data set, so you can grab it. And we're gonna strip out the ID and the topic columns. All we want is the actual conversation called dialogue and then the summary. And this is what we're gonna use to fine tune. Okay, so just printing things out here. Now, we're gonna use this function here to wrap each of the dialogue and the summary into what we're gonna use for the instruction prompt. And that's how we're gonna do the instruction fine-tuning, is the term, okay? And we're gonna convert this text into JSON lines. So if you've used any of our APIs, you know SageMaker, Bedrock tends to like JSON line format. So that's what we're gonna use here. And if you just pull it up in a table, this is what it looks like. Okay, and I only pulled in 1,000 rows, seemed to give pretty good results. So start small and add as needed, just to save cost. Here's those S3 buckets that Kishore was mentioning. This is for the input. So this is where we're gonna have to do the upload from our local to the S3 location. Here's also the output location. All pretty much boilerplate. I just copy and paste from other people's examples for the most part. And then we're just gonna give it a name. First, the age-old trick of using timestamp or the number of seconds since 1970. And we're gonna call create model customization. We give it the customization type. So keep an eye on this parameter. This is how we'll switch to continued pre-training in the next demo, okay? We could specify hyperparameters. Yeah, so just like Kishore said, start with some either academic papers or other people's work to figure out sort of where to start. Well, yeah, start with the defaults that the model provider has specified, and then you can tune from there based on research that you find from similar domains. Okay, and then, so this is what the model looks like in the console. And I think by now, yeah, everything's been released. So yeah, otherwise you might see some, yeah, I think everything's been released because it's Thursday. And here's the actual training job name. You can click in there. Here's the source model. So that was the Llama 2 13B. And here's our hyperparameters, the input location, and the output data, okay? And so now that the model's trained, yes, I did that offline before walking in here. And now you want to provision that custom model to sit behind the Bedrock API. And so from now on, whenever you invoke the API, you specify the custom model name, right? Which I put into a variable up here somewhere. So let's get to, and then this is what the, it's called provision throughput. So, this is where you can purchase model units. You have to look and see what a model unit is and get down to that level. But once this endpoint has been provisioned, you can scale this up as you need. And let's see, what else is here? Ways to tag it. And then here's the actual model that the endpoint is serving, okay? Now, because it's a Llama 2 model, you have to know how does Llama 2, what's the proper format to pass in to Llama 2, right? So there's some tricks, or there's conventions that these models follow. Again, find the model card, figure out what needs to be passed in. So here's an example, or yeah, here's that same example. We're showing similar output here. So this is the base. So here I'm using Llama 2 13B chat. That's right, like essentially that is the chat variant of Llama 2. It's pretty chatty, like I said. And now let's use the fine-tuned version. And here, so here I pass the provision model ARN, which came after I provisioned the endpoint. And now I get a nice, crisp, clean. And so this is the example where we're trying to change the style or change the actual output. So this was a good use for fine-tuning. Okay. Yes, I should make it clear too, just like Kishore said, and like Anand said, start with RAG, which we didn't cover. I'm sure since you're all generative AI folks were interested, you've probably seen a bunch of RAG talks already. There's a lot of examples. This would really be sort of stage 2, where you want to change the actual style of the model responses. Okay, and then delete the endpoint. All right, so let's switch gears to continued pre-training. This is a fun one. Actually, the hardest part, so now continued pre-training, just to back up a sec, this is where I can just pass in unstructured data. I could just give it a PDF and it'll continue to what's called pre-train, right? These foundation models have been pre-trained by Meta, by Cohere, by the Anthropics, the AI21s. And we might want to introduce new terms and shift those like distributions, right? The weight distributions, shift those probabilities to learn your set of documents, okay? And the hardest part was trying to find something that Titan, or sorry, that Llama 2, or no, oh no, yeah, sorry, actually I'm using Titan for the continued pre-training. It's hard to find data that Titan hasn't seen already, right? Especially because most data we're getting from public data sets. So fortunately, oh yeah, and then we're gonna follow the same structure setup. We're gonna test the base model before continued pre-training, upload the data, and then provision. So I'm actually gonna use LangChain. Some of you might be familiar. I think this is a pretty standard library by now to coordinate your generative applications, your Gen AI applications. They also have good libraries to convert like PDFs into text and chunk it up into text, and then that's what's actually will feed in as JSON lines into the continued pre-training. So I'll show you how that looks here in a sec. Doing some more pandas magic, getting the control plane ready for me to invoke the job, and then the data plane ready to do the model inference. Here we are going to use Titan Express. There's, I think there's also Titan Lite. You sure? Yeah, Titan Lite. So yeah, like I said, it was hard to find data, and then this book just came out. So I know Titan hasn't seen it because it hasn't been released yet. It's going to start shipping, I think, next week. So it's a 300-page book. This was authored by me and some of my coworkers. And we actually convert this into JSON lines. Oh, and so, yeah, just to kind of back up a sec, I'm going to ask the base Titan model, Titan Express, that has not been customized, to please describe this book. Now, of course, since the model's never seen this data, it actually starts to kind of pretend like it does. So here we see some like hallucinations. This is Titan trying to be friendly, trying to come up with something that could have a title, generative AI on AWS. So I know, because I was one of the authors, that this isn't really what the book is about. In fact, I don't even see Bedrock being called out. I see SageMaker being called out. I see some of the other services, Recognition and Transcribe. So without customization, and so now I want to introduce my own documents, which is this book, and I'm going to convert it. So here's the actual PDF. I'm going to use some of these LangChain libraries that I use for my RAG code. I can reuse this to just split up this document into chunks, and it like roughly does about 1 page. I figured out a way so that the size of the chunks and the overlap gives me about 1 line item per page. It just happened to work out that way. Seems to work well. So this is just boilerplate code that's going to convert this into the JSON lines format. If you remember on Kishore's slide, he showed for continued pre-training, you have to pass just the input. So there's no completion here, right? There's no output, because I'm not fine-tuning. I'm just giving it raw data. Okay? So about 305 pages. We're going to upload the data. Pretty straightforward. Now, here's where we launch the job with continued pre-training. So not the fine-tuning. Slightly different hyperparameters for continued pre-training. This is something to keep an eye on if you haven't done a lot of like continued pre-training. You want to increase the epochs typically, and then also reduce the learning rate a bit. Yeah, I actually had to work with some of the Amazon scientists to try to find a good balance here. So yeah, always good to have an Amazon scientist on the team. So let's take a look at this model. This is after it's been trained. It's based on Titan Express. And if I keep going, here's the provision. So I call on the Bedrock control plane, I say create the provisioned model throughput. This is a long like API way of saying, like create this specific like endpoint for this customized model. And now I can invoke it. And so let's see what it gives. Oh, and then here's what's called provision throughput. This is where you would select the model units like we did with the fine-tuned model. So all of this is now the same. Okay? There's going to be different, well, actually, it's the same input here. And I say describe the book. And now let's see what it returns. So we see, oh wait, yeah, sorry. Yes, I made this mistake while I was going through my head too. That was the same as before, and now this is the actual custom pre-trained. So there, past the like ARN, which is the unique ID for that model, for the provisioned endpoint. And we see now there's info here on Bedrock. There's also the way that we broke the book down is data preparation sort of throughout the life cycle, right? Like starting with your data, getting to the generative model, optimizations, the evaluation. And so this is much closer to what we actually wrote. Okay? So what we've done is we've essentially shifted the token probabilities, right? When I'm trying to predict the next token, I've shifted those probabilities to now start to predict based on more information that we've given to the model. Okay, and there's all the code. That's the end of the demo, and I think we're going to take questions offline. Is that right? Okay.